So let's start with Unit 6, General Principles and Processes of Isolation of Elements. So most of the elements are well extracted from Earth's core, isn't it? So it is rarely found that ore contains only desired substances. It is usually contaminated with earthily or undesired materials known as gann. The extraction and isolation of metals from ores involve different steps, and following are the major ones. First step is to concentrate the ore. Because when minerals are digged out from the earth crust, they are well contaminated with lot of many undesired substances. So before extraction from them, we need to first concentrate that particular ore of a desired substance. Then after concentration, you isolate metal from its concentrated ore. So isolation is next step. Isolation of metal from the concentrated ore. And next step is, after concentration, you purify, because here after isolation you may not have 100% or 99.99% of purity. So to get higher purity of that particular element or a metal, you purify that concentrated or isolated ore, not concentrated but isolated ore. So next step is purification. Okay. This entire process of isolation of a metal from its ore is known as metallurgy. This entire process is known as a metallurgy. So in this particular unit, we are gonna look into effective methods of concentration of ore. Then we are gonna see different isolation methods such as chemical methods or electrochemical methods. Then we are gonna see different effective purification methods of those metals. Now let's understand where exactly these metals are occurring in our earth crust. We know on our planet elements are abundant in various amounts. Among the metals, aluminium is one of the most abundant element. It is the third most abundant element in earth crust, that is somewhere around 8.3% by weight. It is the major component of many minerals including mica or clay. Many gemstones are impure form of Al2O3, aluminum oxide, and impurities are something like chromium, cobalt. Now chromium is present in ruby, Cobalt is present in a sapphire. Iron is the second most abundant metal on the earth crust. It forms a variety of compounds, and their various uses make it a very important element. It is one of the essential element in biological systems as well, and that's why you have seen you have seen it in many biological processes, such as transport of oxygen in our human body using hemoglobin. In that porphyrin ring structure, you have at the center an ion. So in many biological systems, iron is useful. Now you can see different type of ores of aluminium, iron, copper or zinc in following table. Of course, this is from your book only, the NCERT book. Okay, so aluminium ore is a bauxite. Then iron ores are hematite, magnetite, siderite, iron pyrites. Then copper ores are copper pyrites, malachite, cuprite, copper glans. And zinc ores are zinc blende or sphalerite, then calamine and zinc Si. These are mainly either sulfides or oxides or carbonates or hydroxides of these different metals. Now for the purpose of extraction, bauxite is chosen for aluminium. For iron, usually oxide ores which are abundant and do not produce any polluting gases such as sulfur dioxide are taken. Many pyrites like iron pyrite FeS2 produces SO2, and that's why iron pyrite is not kind of a good ore to produce iron. For copper and zinc, any of the listed ore in this table may be used depending upon availability and other relevant factors like economic factors. Before proceeding for concentration ores, the ores are graded and crushed to the reasonable size so that it can be further pulverized, then it can be processed properly. If you don't have even kind of a particle size, then processing that ore becomes difficult, and that's why it needs to be graded, then crushed to the reasonable size. So further, the concentration of ores. What is exactly this concentration of ore process involves? It involves a removal of unwanted materials such as sand, clay, etc. from the ore. So when we dig the earth crust, you get a sand, clay or different rocks or some other particles or substances which are undesired. To remove them and make that particular ore as a main component of a mixture is something called as concentration of ore. It involves different type of steps, and selection of these steps depends upon the difference in physical properties of the compound of metal present and the gangue. The type of a metal, the available facilities and the environmental factors are also taken in consideration. Some of the important procedures are, as we are gonna see further. First method of concentration of ore is hydraulic washing. Hydraulic washing is based on the difference in gravities of ore and the gangue particles. It is therefore a type of gravity separation. In one such process, an upward stream of running water is used to wash the powdered ore. The lighter gangue particles are washed away and heavier ore particles are left behind. So using hydraulic washing, we separate the gangue and ore. Let's try to understand this particular process with a three-dimensional kind of a cartoon. Okay. This is definitely not my video. I have actually browsed it from the internet.
This is based on the differences in gravity of the ore and the gangue particles. It is therefore a type of gravity separation. Cassiterite is concentrated by this method. The Lillfly tables are specially made tables for washing of ores. The ore is ground to a fine powder in ball mills. Then the powder is washed with a current of flowing water. Lighter gangue particles washed away and the heavier ore particles remain behind at the bottom.
Then there is a second method, magnetic separation. This is basically based on the difference in magnetic property of ore components. If either ore or a gangue is capable of being attracted by magnetic field, then such separations are carried out. The ground ore is carried on a conveyor belt which passes over a magnetic roller, and so the non-magnetic particles are thrown away, whereas magnetic particles are like kind of sticked for a while, and then from that ore it gets like separated. Okay, let's understand this in schematic manner. So the ground ore particles are moved on this moving a conveyor belt. This may be of a rubber or something like that. These are the magnetic, this is particularly a magnetic roller. Due to this magnetism, the magnetic ore particles are separated, or they try to stick for a while and get separated in another maybe a container, and non-magnetic or magnetic particles, they are thrown away. Now there are two possibilities. Your magnetic ore contains magnetic material which is of a desired material, and non-magnetic gangue particles. So here it will be unwanted different material, whereas this will be a proper concentrated ore. In some cases, the gann particles are magnetic and ore particles are non-magnetic. So this will be a part which is desired concentrated ore, whereas this will be non-desired gann particles. Okay, try to understand the difference between. Then there is next method, fourth flotation method. In this particular method, it is generally used to remove a gann from sulfide ores. In this process, the suspension of powdered ore is made with water. To it, collectors or fourth stabilizers are added. They are basically surfactants. Collectors, for example, pine oil, fatty acids, xanthanes, etc., enhances non-wettability of mineral particles, and fourth stabilizers such as cresols, anilines stabilizes the fourth. The mineral particles become wet by oil, which while the gann particles by water. A rotating pedal agitates the mixture and draws air in it. As a result, fourth is formed, which carries the mineral particles. The fourth is lighter and is skimmed off, means taken out from the surface. It is then dried for recovery of ore particles. Sometimes it is possible to separate two sulfide ores by adjusting the proportion of oil to water or by using depressants. For example, in case of an ore containing zinc sulfide and lead sulfide, the depressant used is sodium cyanide. It selectively prevents zinc sulfide from coming to the fourth, but allows lead sulfide to come with the fourth. So that's this third method, fourth flotation. And last method is leaching. This is typically a chemical reaction involved method. It is often used if the ore is soluble in some suitable solvent. For example, now let's understand leaching of alumina from bauxite. A principal ore of aluminum is bauxite. It usually contains silica, iron oxide and titanium oxide as impurities. Now, concentration of ore is carried out by digesting the powder of ore with concentrated solution of NaOH at 473 to 523 Kelvin and at 35 to 36 bar pressure. This way, aluminum oxide is leached out as a sodium aluminate and silica leaving behind the impurities as it is. So the reaction involved here is alumina reacting with NaOH I'm not writing any specific solid, aqueous or liquid, that kind of physical states, just to write that faster. So sodium aluminate is formed. aluminate in solution is neutralized by passing carbon dioxide, and hydrated alumina is precipitated out. So further, the reaction of this sodium aluminate with carbon dioxide is CO2, particularly in gas, is bubbled through this solution to give alumina, Al2O3, and with a different water of crystallization plus sodium bicarbonate. Now sodium silicate remains in the solution and hydrated alumina is filtrated off. So that's how you get a pure, kind of a pure aluminum hydroxide with or hydrated alumina. Now upon heating at 1470 Kelvin, the water of crystallization evaporates off, and then you get a proper pure alumina in a solid state. The other example of this kind of leaching is particularly in separation of a silver and that of gold. The respective metal is leached with diluted solution of NaCl, sodium cyanide or potassium cyanide, in presence of air, for which the metal is obtained later by replacement. So let's say Ag, we are taking example of Ag plus, or metal in a solid state, sodium cyanide or any cyanide solution is used. That gives you this is in presence of air. That gives you a cyanide complex, a metal complex. This is in aqueous stage plus hydroxide ions. Okay. Now the silver ions are present in a cyano complex, that is in aqueous phase. They are reacted with zinc, solid zinc, so that zinc forms a complex with the cyanide and the reduced silver metal is precipitated out. So that's how the equation becomes this zinc cyano complex, zinc tetracyanate, remains in the aqueous solution, whereas the silver metal is precipitated out. Now this is this kind of a reaction is gonna happen only with silver, not with any other metal which is present in the ore of a silver as an impurity. And that's how this leaching, chemical leaching, is used to concentrate the silver ore. Now let's understand these all processes in typical cartoon form. Okay, Let's watch some video about these so that we get a better understanding of.
Ores are found in the earth crust and contain one or more metal compounds along with certain non-metallic and earthy impurities. The extraction of a metal from its ore involves several physical and chemical processes such as the concentration of ore, isolation of metal from the concentrated ore, and purification of the metal. All these processes are collectively referred to as metallurgy. In this module, you will learn in detail about the first step of metallurgy, the concentration of ore. Concentrating an ore means getting rid of all the unwanted materials from the ore, which are also referred to as the gangue. Depending on the properties of the ore and its gangue, the methods used for concentrating an ore may include hydraulic washing, magnetic separation, froth flotation, and leaching. Let's first learn in detail about the method of hydraulic washing, which is based on the difference in the gravities of the ore and the gangue particles. In hydraulic washing, powdered ore is spread on a sloping floor having grooves. When a stream of water is allowed to flow over the ore, lighter gangue particles get washed away, leaving the heavier ore particles behind within the grooves. In magnetic separation, powdered ore is passed over a conveyor belt running over two rollers, one out of which is magnetic. The magnetic particles get attracted to the magnetic roller and travel a distance with the conveyor belt little longer than the non-magnetic particles. Therefore, the non-magnetic particles drop down first, forming a heap, whereas the magnetic particles drop down a little later, forming a separate heap. The next method used for concentration of ore is the froth flotation method, which is based on the difference in the wetting properties of the ore and the gangue particles. The froth flotation method is used exclusively for sulfide ores, where the ore particles are wetted by oil, while the gangue particles are wetted by the water. In the froth flotation method, the powdered ore is mixed with water and small amount of fine oil. The resulting mixture is then agitated by blowing compressed air through it. The oil in the mixture forms froth with the air. The froth rises up to the surface containing the ore particles. The gangue particles, on the other hand, settle down in water. Froth is then collected in another container where it is washed and dried to obtain the concentrated ore. In the leaching method, the powdered bauxite ore is treated with hot and concentrated solution of sodium hydroxide. The ore dissolves in sodium hydroxide to form sodium aluminate, and silica dissolves to form sodium silicate. The other impurities, however, remain undissolved and are later filtered out. The filtrate containing the sodium aluminate and sodium silicate is further treated with carbon dioxide gas. This leads to the precipitation of the hydrated aluminium oxide, leaving behind sodium silicate in the solution. The hydrated aluminium oxide is then filtered out and heated strongly to form pure aluminium oxide. In this module, you have learned that naturally occurring chemical substances containing metals are called minerals, and those minerals from which metals can be extracted conveniently and economically are called ores. The extraction of a metal from its ore involves several physical and chemical processes, namely concentration of ore, isolation of metal from the concentrated ore, and the purification of the metal. Concentration of ore means getting rid of all the unwanted materials, which are also referred as gangue from the ore. Commonly used methods for the concentration of ores include hydraulic washing, magnetic separation, froth flotation, and leaching. Hydraulic washing is based upon the difference in the gravities of the ore and gangue. Magnetic separation is based on the difference in the magnetic properties of ore and gangue particles. leaching process is based on the difference in the wetting properties of the ore and gangue particles. Leaching process is used when the ore particles are soluble in such a solvent in which the gangue particles cannot dissolve.